You see my screen? Hello?
Yes, sir.
Yes, sir.
Okay, so our topic is congruences in the number theory. So I will start with the definition of what congruences are. So congruences, so A is congruent to B modulo M in symbols A, and then it's like an equal pero na ikatulo, no? Duhara mo na sa equal. So tulo na siya kabuok ka horizontal line. A is congruent to B modulo M if and only if M divides A minus B, where M is greater than 0. So wala kayong negative na M sa sulod, ha. Sige, let me try first. Pointer pen. Okay, we have here an example. 1 is congruent to 5 modulo 4. Why is it correct? Because based on the definition, A is congruent to B modulo M. So if A is our 1, B is our 5, and then M is 4, if and only if M, so M is 4, 4 divides what is A minus B. Our A is 1 minus our B is 5. 4 divides negative 4. Is this correct? Because you can get a number, right? Hello, guys. Is this correct? Because you can get a number where negative 4 is equal to 4. Such that here our B is, diba, M na nato siya. If it divides, because we can get an integer where negative 4 is equal to 4 times something, right? And we can get a negative 1 here, which is also an integer, so it's correct. This is true that 4 divides 1 minus 5 because we can get a number that we can multiply with 4, that we can get negative 4, and it's negative 1. Also, that idea is also correct with the second one because, diba, atong balikan na atong given. So this is A, B, and this is M. So you have here M, so 11 must divide A minus B. Our A is negative 2 minus 9. So we have 11 divides negative 11. So based on the definition of divisible, or it divides, no, negative 11 divides negative 11, we can find an integer that we can multiply with 11, and with that we can get a negative 1, no? So you can find an integer that will multiply to 11 to get a negative 11, and we have 1. So this is also true. Where did we get that? That's based on our definition, no, of divide. And also the other one, 6 is congruent to 20 modulo 7 because this is our A, our B, and our M. So 7 must divide 6 minus 20, and then that's just equal to 7 divides negative 14. Tama? And then I think we can get a number that if we multiply with 7, you can get negative 14, and that is negative 2. So this is also true. So that's based on the definition of divide. And also, if we have 720 is congruent to 0 modulo 10, so it is 10 divides 720 minus 0. So you have 10 divided 720. So still, we will find a number that is equal to 720, where 10 is multiplied to something, and that is 72, right? So we can find a number still. So this is also true. But later, I will discuss it using remainders, because when you say modulo, you are just getting those classes with similar remainders later. So it's like, if you say modulo 11, it's like divided by 11. If you say modulo 2, it's just like divided by 2. If you say modulo 3, it's just like divided by 3. Or you skip counting by 2, you skip counting by 3, something like that. So let's try to answer this exercise. For the first one, is 91 congruent to 0 modulo 7? Hello, guys. Is this true or false? Hello? Hello, is it true or false? Hello, guys. Say, can that be true or false? Miss Dagangon, is it true or false? Hello, is 91 congruent to 0 modulo 7? Who could share? Miss Trisha, is it true? You're raising your hand. So let's check if Trisha is correct. That is true. So you have here, let's check if 7 divides 91 minus 0. So 7 divides 91. Okay. Can we find a number that is 91 equal to, that is 7 times something? What is 7 and 91? Or can we divide 91 with 7? It's 13, right? So therefore it's true, because we can find an integer, no, that satisfies this. So this is true. How about the second one? 3 plus 5 plus 7 is congruent to 5 modulo 10. Is this true or false? You can just raise your you can just put emoticons if it's true or false. Like you can have a like if it's true. Okay, Trisha is saying that it's true. So let's check. Okay, 3 plus 5 plus 7 is 15. So you have here is 10 divides 15 minus 5. So 10 divides 10. Okay, this is true, because 10 is equal to 10 times 1. Okay. How about the third one? Negative 2 is congruent to 2 modulo 8. Is this correct? Okay, let's check. So you have here 8 divides negative 2 minus 2. So 8 divides negative 4. Is this true? Will 8 divide negative 4? Or can we find a number with negative 4 that 8 is multiplied to, that is an integer? Can we find? No, right? We can just find a fractional number, but it's not an integer. So this is false. So this one is false. Okay, how about the second one? 11 squared is congruent to 1 modulo 3. So you can just, what is 11 squared? 121. Or you can just write it as 121 is congruent to 1 modulo 3. So you have 3 divides 121 minus 1. So you have 3 divides 120. Or can you find a number that is equal to 120 where 3 is multiplied into? Or you can just divide 120 divided by 3. So that is 40. So I think that's also true, because we can find a number when multiplied by 3. This is true. Okay. Any question about this? Is this clear? Hello, guys. You can just give a thumbs up if it's clear. Okay, thank you, Trisha. Okay, let's continue. So we just verified the examples making use of the definition. But now let's go deeper into congruences. Okay, we have here the first theorem. A is congruent to B modulo M if and only if there is an integer k such that A is equal to B plus km. I am supposed to give you the proof here, but I think I'll just give it to you as an activity later, or part of your seat works on how to prove this one. But I'll shed light a little about this theorem because we'll be making use of this later. Okay, A is congruent to B modulo M if and only if there is an integer k such that A is equal to B plus km. Take note of this. With this theorem, you can express congruence in terms of equation. Ang imong congruent, mahimong equation. Kani siya nga theorem magigamit. So example, if you say n is congruent to 7 modulo 8, it's just the same with n is equal to 7 plus 8k. So, mura siya parehas with atong division algorithm. Remember mo atong division algorithm? Nato nga, a is equal to r plus bq, something like this. Di ba? Ito atong division algorithm. Okay, same siya, Ana. Because the 7 here is just the remainder, right? Yan. Wag kani ang remainder. Si 8 ang divisor, something like that. Kaya siya ang divide, no? So, meaning, kung imo na siyang i-layman's term, n leaves a remainder of 7 when divided by 8, no? Example, na kay number, gi-divide nimo sa 8, ang iyang remainder kay 7. Right? Yan na siya yung pasabot, ana. So example, 1 is congruent to 5 modulo 4 means that 1 is equal to 5 plus 4k, where we can find k an integer, and then we can find a number -1, integer -1 here. If you have 16 divided by 5, that is just equal to 3 remainder 1, right? So you can just write it like this. 16 is congruent to 1 modulo 5. Something again. Because it's like telling us 16 is equal to 1 plus 5k, wherein our k is the 3. Kana siya. Or it's just 1 plus 5 times 3. So it's just 16 ka na siya. So ingana iyang pasabot. No? For example, you have 20 divided by 3 siguro ka na siya. So if you will write it as a modulo, you can just divide 20 divided by 3. I think that is 7, 6, 12, 18. So this remainder 2, right? So you can just write it as 20 is congruent to, the remainder is 2, modulo, what is the divisor? 3, kana siya. Because you can write that as 20 is equal to 2 plus 3 times k, and the k is 6. Tama. For k is equal to 6 because if that is 6, 18, 19, 20. Okay. Do you have a question on this? Hello, guys. Klaro ba siya? Hello? So, okay, let's continue to the second theorem. Theorem number 2. Every integer is congruent to modulo m to exactly 1 of 0, 1 to m minus 1. So it talks about the remainder, no? It talks about the remainder. Kung naa kay modulo 5, so naa kay 5 ka remainders. Yan na siya. Na possible. But it starts with 0. So 0, 1, 2, 3, 4. Wala kay remainder nga 5. 5 man na tanan imong kuan. So m minus 1 meaning kay imong modulo kay m kay 5 minus 1. So 4 imong pinaka last nga remainder dala nga sa baba. The theorem above tells us to make use of the division algorithm by letting any integer be the dividend. M so any integer be the dividend. Muna itong gibuhat ganiha. M as its divisor, K so M as the divisor, K as the quotient, and R as the remainder. Muna itong gibuhat ganiha. Muna ito siya itong relate sa division algorithm. So it's A is equal to R plus KM, or A is equal to KM plus R, parehas naman na sila. So here is the remainder. Remainder. Kani din si M divisor. No, muna itong gibuhat ganiha nga murag ka si 6 divided by 3 or like that. Because the division algorithm R is unique. By the way, our remainder must be must be less than the M, less than the divisor, but greater than or equal to 0. Dili pwede negative at ang remainder ng ibutan. Dapat kuan siya. Dapat siya positive. So muna sa 0 taga-sugod. No? Example, if you have modulo 4, when you say modulo 4, it's divided by 4. No? So the remainders in modulo 4 are 0, 1, 2, 3. Like, example naa ka sa modulo 4, naa ka si, example, si 1 divided by 4. Pila ang iyang remainder. Si 2 divided by 4, pila ang remainder. Si 3 divided by 4, pila ang remainder. Si 4 divided by 4, pila ang remainder. That's the remainder 0, right? Si 5 divided by 4, that's remainder 1. Si 6 divided by 4, that is remainder 2. Si 7 divided by 4, that is remainder 3. Si 8 divided by 4, that is remainder 0. Pag 9 divided by 4, balik na mo ka og 1. So kabalik siya. Like ni kung inkag 3 divided by 4, that's remainder 1. If you say 2 divided by 4, that's remainder 2. If 1 divided by 4, that's remainder 3. Wala na siya nag-minus with 4 minus 1, pila gani? 3. 4 minus 2, pila gani? 2. 4 minus 3 gani? Pila? 1. It's just similar with your abstract algebra. Di ba you have modulo classes in abstract algebra? Were you done with algebra or you're just taking it right now? Hello, guys. Maybe later I'll shed light on this. Kanisa. Ano si 1 divided by 4 kay remainder 3 sa number theory? No? Ano nga siya? Sige, later. Okay, you don't have a question on this, so I'll just continue. So when you say list residue of a modulo M, it's just the remainder. For example, find the list residue of 71 modulo 2. That's 1. You just divide 71 with 2. What is 71 with 2? 71 divided by 2 is 35. No? 71 divided by 2 is 35, remainder 1. So that's why the least residue is 1 because it's remainder 1. How about 71 modulo 3 is 2? Because if you divide 71 divided by 3, you will get 71 divided by 3 is 23. So this is 9, 69. So you'll get a remainder of 2. Tama? No. And so on. So 71 divided by 5 is 1, remainder 1. 71 divided by 7 is remainder 1. And 71 divided by 11 is remainder 5. Okay, you try this one. Kindly try this one. What is the least residue of 23 modulo 11? And then 29 modulo 11. 31 modulo 11, 37 modulo 11, and 41 modulo 11. So it's like telling us, what is 23 divided by 11? What's the remainder? So this is 2 remainder 1. So the least residue is 1. What is 29 divided by 11? That is 2 remainder. What's the remainder? 29 divided 11. That is 2 remainder 7. Okay, so that is 7. and so on. So in that case, we can say that this is, if in this case, that is 2 remainder 9, I think. So that is 9. And here that is 2. I think that is 3 already, 33. So remainder 4. So this is 4. And this is 3 still, remainder. We have 8. So 8. So ang iyang mga least residue is 1, 7, 9, 4, and 8. So how about this one? 16 is congruent to blank modulo 5. How will you answer this? It's like telling us what is 16 divided by 5. Okay na siya. So it's just what is 16 divided by 5. So we're just looking for the remainder. So this is 3, remainder 1. So the answer here is 1. So it's 16 is congruent to 1 modulo 5. Here, this is just telling us 20 divided by 3. So this is 6, remainder 2. So this is 2 here. Okay. Question on this. Klaro ba siya, guys? Hello? Jason, klaro siya? Hello, can you still hear me? Klaro siya. Okay, thank you. So the next theorem is that A is congruent to B modulo M if and only if A and B leave the same remainder on the division of M. So example, kung the same sila og remainder, like for example, 71 modulo 2, I mean dapat the same sila og modulo. Like here, wala example nato din sa 23 nung 1 tanan. Example, if na kayo makita ang kanikang 23 modulo 11 nga 1 yapon ang remainder, pasabot ana the same ra sila. Nga na iya ang idea. So maybe let's have an example. I think I have an example here. Okay. Okay, the example for this theorem is that 1609 is congruent to 1215 modulo 197. Why? Because 109 and 1215, if you get that their remainder, they are the same in modulo 197. Okay, let's note that one. Okay, 1609 divided by 197 is 8. Remainder, wait if you have 1609 divided by 197, that is 8. Remainder, uh, 1609. 197 times 8 equals 1576 minus 160. Okay, remainder 33. Okay, let's check if they have the same remainder with 1 to 15. Okay, if you have 1215 divided by 197, do they have the same remainder? So 1215 divided by 197 is equal to 6. And then remainder 197 times 6 minus 1215, 33. Take note, they have the same remainder of 33. So you can just write them like this. 1609 is just congruent to 1215 modulo 197 because 1609 is equal to or is congruent to 33 modulo 197 and 1215 is congruent to 33 modulo 197. They are the same. Nakuha siya yung point, guys. Hello? Okay, so kana iyang point ha. Jason, klaro ba siya? Nga kung parehas sila og remainder og modulo og divisor, the same ra sila. They are of the same class. kung imo siyang i-drawing gamit later ang katapitang sa abstract algebra nga mag-drawing kag circles sa congruence classes or modulo classes sa abstract algebra. So makita nimo nga of the same circle ra sila, meaning the same sila og remainder. Sige, let's have this one. Kani siya. There are also properties of congruence that we have. One is that for A congruent of A modulo M, where M is greater than 0. So reflexive property. So it's like telling us that 5 congruent of 5 modulo something. No? Example na kay divisible sa koan. So A is congruent to A modulo M. Ingana siya nga koan. Another is if A is congruent to B modulo M and then B is congruent to A modulo M, then M is greater than 0. So example lang nato, maghatag ta din ni modulo 10 siguro. Try, dili niya siya tinuod ha, sample run eh. Okay, I don't know if you divide it with that, that's correct. So this one. So if you have 5 is congruent to 2 modulo 10, then you can have 2 congruent of 5 modulo 10, something like that. Yan siya, symmetric property, no? Pwede mo siya i-interchange. Like, nag-ingon ka nga 5 is congruent to 2 modulo 10, then 2 is congruent to 5 modulo 10. Gano'n man siya? Because they are just the same, no? Remainder ang maguna siya, kani siya. Ang pag-take ani is remainder. But ani nga case, siya ang pinaka-lowest na remainder. But here, murag, kuan siya. No? I-change lang. Number 3, if A is congruent to B modulo M and B is congruent to C modulo M, then A is congruent to C modulo M. So that's transitive property. For example, if you have 5 is congruent to 2 modulo 10 and 2 is congruent to example 3 modulo 10. Example lang na siya ha. I'm not sure kung tinuod ni siya kung ipanghatag ang examples. Then you will have 5 is congruent to 3 modulo 10. Kiwala si 2 kaya balik-balik man siya. No? Or in the same case, if you have 5 is congruent to 2 modulo 10, then you can have maybe if you have another number like 5 plus 2 is congruent to 2 plus 2 modulo M. So pwede siya addition, pwede po ka subtraction, pwede po multiplication, no? And same with the other one kana siya. Pwede po lahi-lahi nga numbers. Kana. Pwede ka multiply even, pwede ka nga na powers. So maybe let's have the remarks. I'll end it with this, then we have examples. Congruence acts like equality in many ways, and then the set of integers can be divided into different sets called congruence classes modulo. Example, mag-divide ka by 4. Katong gibuhat na ganiha. Ang imo din makuha nga remainder kani siya. 0, 1, 2, and 3. Kani man siya ang common nga kuan. So mura bitaw kada isa ka integer sa number line imong i-divide by 4. So you can start with 4 divide 4, this is 0. So naadini ang mga remainder. So if the remainder 0, remainder 1, remainder 2, remainder 3. So si 4 na adiri. Pag-abot sa 5, hindi siya sa remainder 1. Pag-abot kang 6, diri siya sa remainder 2. Pag-abot sa 7, hindi siya sa remainder 3. Pero pag 8 na, balik naman siya kay it's a multiple of 4. So meaning remainder 0 kung multiple by 4. Mura ra ka ga-add og 4, no? Kung ga-add ka og like for example here, kung pabaliktad ta sa 4 ha, like 4 man ni siya. So dito to sa 3. Asa dapit ang 3, no? Asa ang kuan sa 3. Remainder 3 siya. Or si 3 is remainder 1. Hindi na siya. 3, 2, and then 1. Sakto ba? Nga si 1 na asa rin. Baliktad. Let's divide. What is 4? What is 3 divided by 4? Ano siya? Kung mag-plus ka og 4 sa iya, kay the same siya sa 7. Asa si 7? Naadiri si 3. So, 1 ni siya. Okay. Kung ano siya, katong mga gagmay pa sa 4, duha na to nimo. Like si 2 plus 4 divided by 4. So, this is 6 divided by 4. That's just remainder 2 mo. Munang si 6 ug si 2, the same ra na sila. Kaya nagka-add ra ka og 4. Like, add ka og 4 dira, add ka og 4, minus ka og 4 dira. Muna makuha nimo ang mga numbers. Like, mag-minus ka og 4 na nakaka-negative 2. Minus ka og 4 na nakaka-negative 6, and so on. So, ang mga numbers is si 2, negative 2, 6. So, kani siya, mag-plus ra ka og minus og 4. May buwan na nimo kinsa yung mga kauban. No? Like, 0 plus 4 o minus 4 is negative 4. Kana siya. Or ingana iya ang grupo-grupo. So, kanita nandini nga numbers, isa ka class, isa ka grupo, same na siya. So, you can write that as, for example, kani siya, you can write it as 8 is congruent to, ang yung remainder kay 0 modulo 4. Kana siya. Or you can write as 4 is congruent to 0 modulo 4. Kana siya. Or you can have, kisa pa yung kauban, si negative 4, right? So negative 4 is congruent to 0 modulo 4. Kana siya. The same ra ba na sila? Or you can even write gani, 8 is congruent to negative 4 modulo 4. Katumpar sa ito kaganihan. They are just the same because they have the same remainder. Kana siya. So same here, you can write this as 5 is congruent to 1 modulo 4. Or you can write it as 1 is congruent to 1 modulo 4. Or you can have 9 is congruent to 1 modulo 4. And so on. Kana. Here's a remainder 2 is you can write 6 is congruent to 2 modulo 4. Or you can write 2 is congruent to 2 modulo 4. And so on. No? Kana siya. So nakita ninyo kung asa si number o katong remainder dito siya. No? So 1 is congruent to 1 modulo 4. And this is one of our properties kanina. No? So same way, you have 7 is congruent to 3 modulo 4. So modulo 4 sa tanan, 3 is congruent to 3 modulo 4. Because ang atong class is modulo 4 man ta. Nakuha ba? Hello guys. Sige, I'll give some examples, no?